Come on, today we are going to talk about heaps. What is an heap? A heap is a complete binary tree. A heap are of two types, min heap and max heap. What is min heap? In a min heap, value of each node must be less than its child node, which is the root node must be the smallest among all the other nodes. And this property is known as min heap property. Let's go through an example. From this example, we can see that 1, 2 and 3 are the root nodes. It satisfies min heap property because 1 is less than their child 2 and 3, 2 is less than their child 4 and 5, and also 3 is less than its child 9. In max heap, the value of each node must be greater than its child node, which means the root node is the largest among those nodes. This property is known as max heap property. Let's go through an example. From this example, we can see that 9, 5 and 4 are the root nodes. Here 9 is greater than their child 5 and 4, 5 is greater than their child 1 and 3, also 4 is greater than their child 2. Heaps are represented as array. We can see it in detail.
Okay, this is a min heap. Here we can see that each node is lesser than its child nodes, so it is a min heap. If we want to represent this min heap in an array, this is the step. First we have to write the root, the top root at the first element or the 0th index. So we write the topmost element or the root at the first element. Then in this order, which is from left to right, we have to represent each element in this array, which means at the layer 2 we have to represent these two in next 2 indexes and next 4 elements in next 4 indexes and at last the 30. This is how we represent it is in array. So if you write in array, it will be in this format. Okay, now we represented it in array. Then how will we know the connections between elements in this array, or which node is the root, or which node is the child, or which is the topmost child, which is the left child, which is the right child? How we know? So there is a relationship which is used here. To know the left child, we use the equation 2i is to I plus 1. Okay, 2i plus 1. Suppose we want to know the left child of 10, which is 10. 10, the element 10 has two child 20 and 22. We want to know the left child. So the element 10 index is 1. So to know that left child, we use 2 into 1 plus 1, which is equal to 3. And in third index, we got the left child. So that's correct. Next we want to know the right child. The right child equation is 2i plus 2. Suppose we want to know the equation right child of 15. So we check the index of 15, which is 2. To know the right child, which is 2 into 15 index is 2. So 2 plus 2, which is 4 plus 2 is 6. In 6th position we got the right child. So 26 is the right child, and we check here we also got the 26 as its right child. Then suppose we want to know who is the parent. Suppose we want to know who is the parent of the child 26, and this equation is parent is equal to I minus 1 divided by 2, which is 26. 26 index is 6, which is 6 minus 1 divided by 2. 6 minus 1, which is 5, and 5 divided by 2, we get 2.5, and if we round it back, we get 2. We should round it backwards. You should know that 2. In index 2, we got the element 15. So the parent of the child 26 is 15.
As you know that a heap is represented as arrays, and generally you are given an array and you want to create heap from that array. So here is an algorithm which is used to generate heap from an array. We will go through this algorithm in detail.
Okay, this is the array we have given here, and we have to convert it into a heap or a min heap. So if you represent it is in a binary tree format, it will be like this format. Root at first, and the next two child nodes at next to left, and next other for nodes at the last layer. So here we represent it. So the first step to find the min heap is, first of all we want to find which is the last parent or the last non-leaf node. Here we can find that 25 is the last non-leaf node or the last parent. So we have to compare the 25 with its child 22 and 12 and find which is the smallest. Here we can find that the 12 is the smallest. So we have to swap the 25 and the 12 in between them. So here it will be 12 and here it will be 25. So it is up. Next we want to find the next non-leaf node or the next last parent. Here we completed, and then the last parent will be 15. And from 15 we have to compare it with this child and find who is the smallest here. And from finding that we know that the 3 is the smallest here. So that's what 3 and 15 in between them. So here it will come 3 and here it will come 15. Okay, the last non-leaf node is also completed. Then we want to find the next non-leaf node or the last parent. So we check the 10 will be the last parent here, and their child are 12, 3 and 12. And next we want to find which is the smallest between 3 and 12, or which is the smallest in this family. So here we can see that 3 is the smallest here. So we have to swap between 3 and 10. So the 3 comes out top and 10 comes here. Next we want to fully check that whether anywhere the child is greater than its or the parent is greater than itself. So in this case it's completed. So finally we got the heap from the or the min heap from the array, which looks like this. The child node or the parent node is less than their child, or the parent node is less than their child. The parent node is less than their child. So the min heap is created from that array. This is the Python code for the heapify function, or to convert or to get a heap from an array. Uh, how to creating an heap from a given array. So this is the Python code. Uh, the code starts from here. Here we are initially defining an array itself. In Python it is a list. As we see, there are a list of numbers here. We are finding the length of that array using len function, and we are simply passing it through the build heap function. Note that the arguments are the array and the length of an array. In build heap function, we can see as you know in algorithm, I have said that first step is to find the non-leaf node. So the equation for the non-leaf node is like this, and from here we get the last non-leaf in start IDX function, in start IDX variable. So the index of the last non-leaf is in here. Here then we are applying a for loop here, starting from that index till -1 with an increment of -1. So in that loop, we are applying the heapify function. Okay, note that the heapify function have the arguments such as array, the total number of elements in an array, and that node itself. Okay, the first step is it is initializing the largest variable as the root itself. That is happening here, and we know the equation for finding both the right and left side of an rock. So we are finding both the left and right hand here. And next we have to compare it with the array and find which is the largest, whether the right side or left side. By applying this code, we get the largest variable as whether the right side or whether the left side, which is the largest itself. So we got the largest child itself. Then we want to just swap it. So the swapping happens here. It is checking whether it is not the root, because if it is root, we don't want to swap it. So it is checking that the largest is not the root. That is confirming it. And then the swapping happens. It is the simple swapping here. As we discussed in the algorithm, you should be clear with that. After that, we are recursively calling the heapify function once more, so that it can be applied to the subtree itself, subtree of that node also. So it is with the code part. Now we can execute the code. As you see that the array will be this, and you can see what happens after we executing this code. So we are executing this code. Okay, you see that the output will be like this. This will be the max heap which is generated from this Python code. This is the output of this. Okay, thanks for watching this video. Welcome.